Hello guys, welcome to Geometrics. We're going to be looking at the structural vector autoregression using Eviews. Previous week ago we had talked about through the YouTube short that we're going to play or demonstrate how to carry out a structural vector autoregression using Eviews. And the question we asked ourselves is that why not with the vector autoregression? Why do we have to use the structural vector autoregression? In the last vector autoregression we displayed, or we talked about, we said VAR is a system of equations where each variable is a function of its own lag and the lags of all other variables. Now the core issue now is that in a standard VAR, the error terms, which are the shocks, are correlated. The Kolesky decomposition imposes a statistical ordering to make them orthogonal, but this ordering might not have a solid economic justification. Now, what is the solution? The solution is to have a structural vector autoregression, the SVAR. The SVAR uses economic theory to impose restrictions on the contemporaneous relationship between variables. This allows us to recover truly structural shocks. In order to understand this distinction between VAR and structural VAR very effectively, we have to use an illustration. Imagine you are in a crowded party. Suddenly you see a chain reaction across a room. What do you observe? You see Mark suddenly jumps back. Sarah spills her drink. Alex lets out a surprise shout. The problem is you can't see what caused all this. You just see the reactions. And that is what the VAR will tell you. That's what exactly the VAR model will tell you. The VAR model will tell you that variables are moving together, but it can't tell you why. Just like knowing Mark, Sarah, and Alex all reacted at the same time, but you have no idea what triggered it. For VAR, you would only see the effect without knowing the causes. In econometric terms, we see the reduced form shocks as the reactions, but we don't know the underlying structural cause. This is where the structural VAR comes in. The structural VAR investigates what really happened. The structural VAR is like a detective. So we use economic theory and logical restrictions to figure out what actually happened. Now when we go by our illustration, the SVAR would simply investigate the three possible causes, and this will go this way. 1. A mouse must have run across the floor. 2. Someone told a hilarious joke. 3. The music suddenly got very loud. Now, each of these causes would create a different pattern of reaction. This is where we impose our structural restriction based on logic. Now, for SVAR, structural VAR have what we call structural restrictions. And what are they used for? These restrictions are used to tell the model how shocks affect variables. The key difference is when these effects happen. For structural restrictions, for the SVAR we have short-run restriction, in SVAR we have long-run restriction. For the short-run restriction, it implies that it affects the immediate and contemporaneous, that is, it affects the variables affects other within the same period. Immediate effect, contemporaneous effect. Now within that short-run restriction we have what we call the AB model. We have the matrix A that captures the contemporaneous relationships between the variables themselves. Then we have the matrix B that captures the instantaneous impact of the structural shocks on the variables. Now for the long-run restriction, it means that what the variables affect each other have a cumulative impact on each other, or there's a cumulative impact of a shock over a very long time. But for this study, the long-run restriction will not be analyzed for a good reason, and the good reason will be given at the end of this video. So please continue watching the video, as you would know the reason why we will not want to do or analyze the long-run restriction of the SVAR. Now we're going to go through the practical steps using Eviews. We'll have a VAR economic model where GDP growth rate is the dependent variable, and the independent variables are the real interest rate and inflation rates. What are the steps to undertake a structural VAR or an SVAR? The first is to check sessionarity. The second is to ascertain co-integration. The third one is to specify VAR equation. The fourth is to select optimal lag length. The fifth is to specify VAR equation with appropriate lag. The sixth is to check model diagnostics. And the seventh is to impose the structural VAR. And the eighth step is to generate structural impulse response. And the ninth step is to what? Undertake the structural variance decomposition. Now for step 1 to step 6, you have to watch the video, the vector autoregression. Yes, step 1 to step 6 requires that you carry out the vector autoregression. So you have to watch the video. And for the SVAR, you should note that variables must be either stationary at first difference but not integrated, or your variables must be stationary at levels. Please note that for the SVAR, your variables, SVAR with short-run restrictions, please don't forget short-run restrictions, your variables must be either stationary at first difference but not co-integrated, or your variables must be stationary at levels. Okay, now we'll move, having done the first to 6th step through that video. The 7th step is to impose the SVAR. How do we do this? We click proc in the VAR object, click estimate structural factorization, and we choose matrix tab, which that is the AB model, and then we click OK. Okay, let's go and do that. Okay, like this is the Eviews platform. Already the VAR had been done. Yes, the VAR had been done. This is the VAR already been done. So you can go and check the video to get to know how the vector autoregression can be done. So in the VAR object, we click on proc, and we click on estimate structural factorization. Now this is the A matrix. We leave it this way. This is the B matrix. This is the B matrix. We also leave it this way. Then we check for the optimization control. We leave them this way, and then we click OK. Now this is what the estimate for the structural VAR. Let us have an expanded view of this for better understanding. Okay, now this is the result expanded view of the structural VAR estimate. Now when we look at the A matrix, you can see the coefficient, which is significant 5% level or 1% level. Then you see GDP growth is not affected comparatively by other variables, but interest rates affected by GDP growth within the period. C1, which is minus what? 1 minus 1.22 approximately. The inflation is affected by both GDP growth and interest rate within the period. Okay, we continue with the interpretation for the A matrix. For C1, you see C1 is highly significant with P, which is a less significant at the 1% level or 5% level. It implies that a 1% increase in GDP growth leads to a 1.22% increase in interest rate contemporaneously. This suggests counter-cyclical monetary policy. When growth is strong, central bank tends to lower rates and vice versa. And for C2 and C3, they are not significant. So I think we do not really have to interpret that, but for the sake of emphasis in the lecture, C2 GDP growth effect on inflation is positive but not significant. For C3, interest rate effect on inflation is negative but not significant. So there are no strong contemporaneous effect. Now the essence of doing this is for us to also know when it comes to the B matrix. You see that C4, C5, C6, they are all significant. They are all significant. C4, C5, C6, they are all significant. 1% level. Now these are the standard deviations of the structural shocks. For C4, the coefficient is 4.95 approximately, which is the size of GDP growth shocks. For C5, this is 11.40, which is the size of the interest rate shocks. For C6, it is 4.51 approximately, which is the size of inflation shocks. Now, our aim of undertaking the VAR estimate is to make sure that the structural VAR is successfully identified. You can see structural VAR is just identified. So we've achieved that. So the next step we have to do is to generate structural impulse response. This is a very important aspect of the structural VAR. Now, in the structural VAR object, click impulse, then choose structural decomposition in the impulse definition. Then we click OK. Let's go back to Eviews. Then we'll click and we click on impulse. We check the impulse definition. You have to click the structural decomposition, very important. Then we click OK. Now this is the impulse response of the structural VAR. So let's have an expanded view of this. Now the reason why we had to click the structural decomposition when it comes to impulse definition, it tells Eviews to use or identify structural shocks from the SVAR rather than the reduced form residuals. Now, if you don't select structural decomposition, you will get impulse responses for the reduced form shocks, which are just statistical artifacts without economic meaning. So now this is the impulse response of the structural VAR. Now for the GDP growth shocks, because the response of GDP growth rate to growth rate, a positive productivity or demand shock boosts growth temporarily. And the response of interest rate to growth rates, if the interest rate falls initially, the negative response, which is counterintuitive. So we expect rate to rise. We expect rate to rise with strong growth, possibly meaning it indicates that CBN is smoothing growth fluctuations or there is liquidity effect. The response of inflation to growth rate, so inflation increases initially, the positive response implies that stronger growth leads to higher demand, which causes inflationary pressures. When we come to the monetary policy shock, the response of growth rates to real interest rates, see growth falls significantly, negative response. We have a classic monetary transmission where higher interest rate leads to lower investment or consumption, which leads to slower growth. Moreover, the maximum effect is about 3 to 4 lags. So the response of real interest rate to real interest rate itself is that shows that interest rates increases immediately, then gradually returns to normal. This is exactly what we expect from a policy shock. The response of CPI to real interest rate is that inflation falls in response to higher rate. This confirms monetary policy effectiveness, where higher rate leads to lower inflation. And then for the inflation shocks, we see the response of growth to inflation CPI, growth falls slightly, possibly meaning is that cost push inflation reduces real income and spending. The response of interest rate to CPI, see the interest rate rises significantly. The CBN reacts, they raise interest rates to fight inflation. This shows the policy response to inflation shocks. The response of CBN, immediate inflation increases, which gradually returns to normal. So this graph shows us the complete dynamic story of what is happening. And the key policy insight is that monetary policy works as expected. We will have higher interest rate reduce growth with a lag. Higher interest rate successfully reduce inflation. The CBI responds strongly to inflation shocks. Then the next key policy insight is growth inflation trade-off is visible. And the growth shocks are inflationary. Inflation shocks reduce growth. And therefore, interesting policy behavior, we see that the CBN appears to lower rates in response to growth shocks. This might indicate a smoothing or stabilization objective. The next thing for us to do is to take step 9, which is to conduct a structural variance decomposition. In the SVAR object, we just click View, we choose variance decomposition, we select structural decomposition, and then we click OK. So we go to our Eviews, we select View, we go to variance decomposition, and we click structural decomposition and click OK. Now this is what the structural variance decomposition of the model. So we have to look at the expanded image through a PowerPoint. Here to the right of it, you see this is the structural variance decomposition concerning the GDP growth story, shock 1. Then you see that growth is dominated by its own shocks in the short run. And then in the medium term, you see it explains what monetary policy explains 11% of growth fluctuations, while inflation shock explains 20%. And in the long run, inflation shocks dominate completely, explaining 96% of growth variations. Now, this suggests that in the long run, it is not monetary policy but inflation shocks that are the main driver of the GDP growth fluctuations in the economy. This could indicate that price stability is crucial for long-term growth. Now, for the interest rate story, let us see that interest rates are mainly driven by their own shocks. It is 78%, indicating active monetary policy. Now, in the medium term, policy shocks and inflation shocks become equally important. And also in the long run, inflation shocks explains 97% of interest rate variations. So this suggests that the central bank initially sets rates actively, but over time they are primarily responding to inflation development. This is consistent with an inflation targeting central bank. Okay, we'll now move to the inflation story. Let's see what the story is all about. Inflation is dominated by its own shocks at all horizons, 7%. Monetary policy explains almost nothing, at 0 to 1%. Growth shocks have minimal impact. And this suggests that inflation is primarily driven by its own dynamics rather than monetary policy or growth shocks. This could indicate strong inflation persistence, limited effectiveness of monetary policy for controlling inflation, and inflation expectations playing a major role. Now, what are the key policy insights for the structural variance composition? You see the monetary policy effectiveness. There's limited short-term impact on inflation, which is only 1%. There's moderate impact on growth, 11% at medium horizon. And also, policy effectiveness is not the main driver of any variable in the long run. So for inflation, we also have inflation dominance. Key policy insight, where inflation shocks are the key driver of long-run economic fluctuations. Why do we say that? They explain 96% of growth variations and 91% of interest rate variations. What about the growth shocks? Growth shocks were very important in the short run for growth, but their influence fades quickly over time. Now, there's something we should note. We should remember that the impulse response showed us that monetary policy shocks do affect growth and inflation, but the variance composition showed us that they are not the most important sources of fluctuations. Now, it's very important for us to look at both aspects, because both aspects are needed for complete understanding of what the structural VAR is all about. Now, what we've done now is the short-run restriction. It is referred to as the short-run structural VAR. But why do we not do the long-run restriction? Like I said earlier, the short-run restriction or short-run structural VAR deals with variables that must be either stationary at first difference but not co-integrated, or your variables must be stationary at levels. The variables I used for this study, the GDP growth rate, the real interest rates, and the inflation rate, they were all stationary at levels. That was why I was restricted to the short-run structural VAR. But since for the long-run restriction or the long-run structural VAR, they deal with the levels data or variables that are stationary at first difference, but assumes no co-integration. So for long run, you need to have variables that are stationary at first difference, but no co-integration, in which you have to use the levels of your data. So maybe subsequent, in a few weeks to come, we will demonstrate that. So if you need the data set for the SVAR video, please contact us via jkametrics@gmail.com. You can also subscribe to our channel and invite other people to also know what it means to undertake a structural VAR using any model, as far as it agrees with economic theory. Thank you very much.